Hello dear students, we will discuss about magnetism today. Magnetism. Let us first know what is a magnet. A magnet is a substance which attracts iron towards it. So that is a magnet. So what are the characteristics of a magnet? Magnet has got two poles, mainly north pole and south pole. North pole and south pole. North pole denoted by N, south pole denoted by S, NS, north pole and south pole. So what is a pole? So the magnetic properties of a magnet are considered the poles. So properties are considered here, as well the properties decrease towards the center. So N is north pole, S is south pole. If you suspend a magnet, freely suspend a magnet, then it will show a particular, remain along a particular direction in the earth magnetic field. The north pole of the magnet remains towards geographic north pole of earth, and south pole of the magnet remains towards geographic south pole of earth. North pole remains towards geographic north of the earth because geographic north pole of earth contains magnetic south polarity, and south pole of the magnet remains towards geographic south pole of earth because south pole of earth contains magnetic north polarity. So our earth is a huge magnet, and when we freely suspend a magnet, it will remain at a particular direction. So then what is magnetic length? What does it mean by magnetic length? Magnetic length. Magnetic length of a magnet. What is the meaning of magnetic length of the magnet? It is defined as the distance between two poles of the magnet. Distance between two poles of the magnet is called magnetic length. It is denoted by, normally it is denoted by 2L. This distance is denoted by 2L. L from the center towards N, L from the center towards L, 2L, magnetic length. Then geometric length is defined as the total length of the magnet. And magnetic length is always less than geometric length. The ratio of magnetic length to geometric length is almost 0.85%, it is 85%. So this is magnetic. What is magnetic axis? Magnetic axis it is defined as the straight line joining north pole and south pole. That is your magnetic axis. Magnetic meridian. Magnetic meridian. Magnetic meridian is imaginary vertical plane passing through the magnetic axis. So if you place a vertical plane perpendicular to NS, then this will be called magnetic meridian. So magnetic length, magnetic axis, and magnetic meridian. Then the most important factor of a magnet is pole strength. Pole strength of a magnet. Strength of a magnet. Pole strength. Pole strength. So the magnetic properties are considered the poles of the magnet. The pole strength is measured by what? By ampere meter. Unit is ampere meter. Ampere meter. Dimension of pole strength is, unit is ampere meter, dimension of pole strength is, ampere dimension is A and meter dimension is L. Pole strength of the magnet is ampere meter. Then now we can discuss about magnetic field. What does it mean by magnetic field? Magnetic field of a magnet. What does it mean by magnetic field of a magnet? If you place a magnet here, anywhere it cannot attract other magnetic substances. So it can attract the magnetic substances within a particular jurisdiction. The particular region over which a magnet has its influence over other magnetic substances is called its magnetic field. Next is magnetic field intensity. Magnetic field intensity. The definitions are important. Magnetic field intensity. What does it mean by magnetic field intensity? Magnetic field intensity due to a magnet at a point in its magnetic field is defined as the force experienced by unit north pole placed at that point. So, students try to remember the definition of magnetic field intensity, because you will come across the same definition in case of electric field intensity. In place of magnet there will be charge only, same definition. Magnetic field intensity due to a magnet, you will get magnetic field intensity due to a magnet. Where? At a point, the point must be situated at which point? A point must be inside the magnetic field of the magnet. If the point is outside the magnet, then there is no magnetic field and no influence at all. So, magnetic field intensity due to a magnet at a point in its magnetic field. The point must be in its magnetic field is defined as the force experienced by unit north pole placed at that point. You place a unit north pole at that point. Actually, unit north pole is not possible. In that case, also very small magnet is taken, little magnet is taken. So, magnetic field intensity due to a magnet at a point in its magnetic field is defined as what? As the force experienced by unit north pole placed at that point. So, now let us discuss about what is the force experienced and how this to get the expression for force. So, for that we have to go to Coulomb's law of magnetism. Coulomb's law of magnetism. Coulomb's law of magnetism. You will come across the same thing, Coulomb's law in electrostatics. Same thing is here, same thing. Only in place of charge, there will be only here will be pole, nothing else. So, Coulomb's law of magnetism states that it has got two parts. First part, like poles repel, unlike poles attract. In case of electrostatics, like charges repel, unlike charges attract. Similar, like poles repel and unlike poles attract. Like poles means what? Two north poles or two south poles. Unlike poles means north pole and south pole. So, like poles repel and unlike poles attract. The second part is the mathematical part of it. The force of attraction or repulsion between two poles is directly proportional to the product of pole strength and inversely proportional to the square of the distance between them. Remember this statement: the force of attraction or repulsion, both can be there, because if the poles will be like, there will be repulsion, repulsion, poles will be alike, there will be attraction. The force of attraction and repulsion between two poles is directly proportional to the product of pole strength and inversely proportional to the square of the distance between them. This type of statement we have come across a number of times. First of all, in case of gravitation, we have come across this statement, gravitational force of attraction. In case of electrostatics also same thing will be there. Only in case of poles there will be charges. So, like force of attraction or repulsion will two in electrostatics, it is charges only. Here it is poles. That is the difference. Same thing is there. Coulomb's law of electrostatics. Here is the Coulomb's law of magnetism. So, it is directly proportional to the product of the pole strength and inversely proportional to the square of the distance. I think you understand what is the meaning of directly proportional to and inversely proportional to. So let us go to the mathematical part of this statement, Coulomb's law of magnetism. What is the mathematical part? Let us consider two poles, strength M1 and M2. Normally pole strength is denoted by small m. So M1 and M2, what is the distance between them? Let the distance between them is r. So the law says that the force of attraction and repulsion between the poles is directly proportional to the product of pole strength. F is proportional to what? M1, M2, product of pole strength. Inversely proportional to what? Square of the distance between them. So this is your mathematical from the statement we have taken it. So F must equal to what? F must equal to is direct proportional to what? You combine both M1, M2 by R square. So F is equal to what? A constant K, M1, M2 by R square. You have come across this like this, proportional to etc. and a constant factor is there. So F is equal to K, M1, M2 by R square, where K is a constant proportionality. Proportionality, you have to mention that. K is a constant of proportionality. And the value of this constant of proportionality is different systems of units. For in CGS unit, the value of K is 1. In MKS unit or SI unit, normally we will discuss about SI unit. Nowadays CGS unit is no more used. So in SI unit, K is equal to what? Mu 0 by 4 pi. Well, K is mu 0 by 4 pi. Now, what is this mu 0? K is mu 0 by 4 pi. So the formula will be what? F is equal to mu 0 by 4 pi M1 M2 by what? R square. This is the final formula. We will use this formula as required. When two poles are there and distance between them is r. What is mu 0? Mu 0 is called permeability of free space. Permeability of free space. Remember this, permeability of free space or vacuum. How it permits the magnetic lines of force to pass. So mu 0 is permeability of free space. Its value is fixed since this. So this is what? 4 pi in 10 to the minus 7 Weber by ampere meter. Weber by ampere meter. Mu 0 permeability of free space, which value is 4 pi in 10 to the minus 7 Weber by ampere meter. So this is your inverse square law of magnetism, by which force two poles will attract each other or two poles will repel each other. Then let us go to magnetic lines of force. Magnetic lines of, this is very important, magnetic lines of force. In electrostatics also we will discuss about electric lines of force, same things, only in electrostatic case we will discuss about charge. In case of this magnet, we will discuss about the poles. Magnetic lines of force. What is a line of force? It is a closed curve. Magnetic line of force is a closed curve in a magnetic field along which a unit north pole moves if it is free to do so. So remember the definition. Magnetic line of force is a closed curve drawn in a magnetic field. In a magnetic, definition of magnetic line of force, in a magnetic field along which a unit north pole moves if it is free to do so. So this is the definition of a magnetic line of force. Magnetic line of force is a closed curve drawn in a magnetic field along which unit north pole moves unit north pole moves if it is free to do so. So, this is very simple way of speaking the path of a unit north pole. A very simple way you can say what is a magnetic line of force? It is the path of a unit north pole in a magnetic field. Very simple. So, what are the properties of magnetic lines of force? Very important from examination point of view. Properties of magnetic lines of force. Properties of magnetic lines of force. Properties of magnetic lines of force. In the examination, normally question comes carrying 2 marks or 3 marks for properties of magnetic lines of force. So, the first property is it is a closed curve in a magnetic field along which the unit north pole moves, it is free to move. So, what is its direction? The direction of first is the direction of line of force is from north pole to south pole, outside the magnet, and from south pole to north pole inside the magnet. So, lines of force, magnetic lines of force exist inside the magnet as well as outside the magnet. This is the only difference between electric line of force and magnetic line of force. Electric lines of force that remain outside the conductor, there is no electric line of force inside a conductor, but magnetic lines of force do exist inside a magnet. The direction of line of force is from north pole to south pole outside the magnet and from south pole to north pole inside the magnet. Second point, it is a closed curve. Along which unit north pole moves if it is free to do so. Closed curve along which unit north pole moves, it is free to do so. Third point, it is a curve so drawn that the tangent drawn at any point of the magnetic line of force gives the direction of resultant field intensity. This is very important. The tangent drawn at any point of the line of force gives the direction of resultant field intensity. This is a very important point, resultant field intensity. If you draw a tangent to a magnetic line of force at any point, the direction of the tangent is the direction of magnetic lines of force. So, tangent drawn at any point of the line of force gives the direction of resultant field intensity. The fourth point is a very important point and very often it comes in examination. From this very important from examination point of view. As the fourth point, two magnetic lines of force will never intersect. This is very important. Will never intersect. Similarly, in electrostatics also, two electric lines of force will never intersect. In the exam question comes, short question, 1 mark question, whether they intersect or not, the answer is will carry 1 mark. But if it is asked to explain, then you have to explain why do they don't intersect. Two magnetic lines of force never intersect because what is the reason? Because if they intersect, suppose two lines of force intersect, at the point of intersection, two tangents can be drawn. The direction of the tangent gives the direction of field intensity. So, at a particular point, there will be two directions of field intensity, which is impossible. So two lines of force will never intersect, because if they do so means if they intersect, two tangents can be drawn, at the point of intersection. So there will be two directions of field intensity. There will be two directions of field intensity at a point, which is impossible, because direction of field intensity at a point is one and only one. So two lines of force will never intersect. It is a very important point from the Jensen point of view. Same question you may get in electrostatics or in magnetostatics. So the properties of magnetic lines of force. Now let us discuss about magnetic dipole. What is the meaning of magnetic dipole? Magnetic dipole. What is a magnetic dipole? Same in electrostatics also there will be electric dipole. So what is a magnetic dipole? A magnetic dipole, two equal and opposite poles separated by a small distance produce a magnetic dipole. Two equal and opposite poles, remember the definition, these are important definitions. Opposite poles separated by a small distance, produce a magnetic dipole. In electrostatics, you will come across the same electric dipole. Two equal and opposite charges separated by a small distance produce an electric dipole. So two equal means pole strength must be same. Opposite means one north, the other is south. So let us consider like this: M. Here is M. Distance of separation is 2L. This is a small distance. So this is a magnetic dipole. Dipole moment. What is dipole moment of the magnetic dipole? How to define dipole moment of magnetic dipole? It is defined as the product of pole strength and the distance between the poles. It is defined as the product of pole strength and distance between the poles. So dipole moment will be equal to what? That is M into what? M into 2L. Pole strength M, distance is 2L, M into 2L. It is a vector quantity. Dipole moment is a vector quantity. As you know, every vector quantity has got a direction. Then if it is a vector quantity, what is the direction? Its direction is from south pole to north pole. Its direction is from south pole to north pole. Then what is unit? These are important from examination point of view, because in the short question they may ask what is unit of dipole moment, what dimension of dipole moment, whether it is a scalar or a vector. All these things are very important. Unit of dipole moment. As you know, what is dipole moment? M into 12. You know the unit of M, you know the unit of L. So in the SI system, this is ampere meter ampere meter into again meter, so ampere meter square. Unit of dipole moment is ampere meter square. Dimension of dipole moment, is very simple. One did not remember it, this dimension, because from the formula you can find out what is dimension of dipole moment. Ampere dimension is A, meter square, L square. Dimension of dipole moment. So you know what is a magnetic dipole, what is the definition of what is dipole moment, what is the unit, what is the dimension, and whether it is scalar quantity or a vector quantity, all these things. Now let us find out the field intensity due to a dipole at end-on position and at broadside on position. I will explain to you what does it mean by end-on position, what does it mean by broadside on position. Field intensity, these are important for long questions. Field intensity due to a magnetic dipole, this may come as long question. Dipole at a point on the axial line, or at end on position, same thing. They may ask in the question, they may ask you point on the axial line or at end on position, you have to understand both are the same. Field intensity due to magnetic dipole at a point on the axial line or at end on position. What does it mean by end on position? Axial line, point on the axial line means the point will be on the axis. So let us consider a magnetic dipole. How to consider a magnetic dipole? North pole, south pole, point is P here, point is P, the central part O. So we have considered a magnetic dipole. NS is magnetic dipole. P is a point, external point on the axis of the magnetic dipole. So this is at a point on the axial line, or that is also called end on position. This is L, this is L, this distance is R. So what is the distance of P from the center of the magnet? Center of the magnet, the distance of P is R. R is distance of the point from O, from the center of the dipole, center of the magnet. We will find out field intensity at P. What does it mean by field intensity at P? Field intensity at P means force experienced by unit north pole placed at P. So let us consider unit north pole at P and find out how much force it experiences due to the magnet. When it experiences force due to magnet means, when you talk of force due to experiences due to magnet means force experienced due to north pole, force experienced due to south pole. Then what is the resultant force? So field intensity at P, is the force experienced by, we have already explained field intensity. Field at P is the force experienced by unit north pole placed at P. Unit north pole placed at P. So let us place unit north pole at P, find out how much force it experiences at north pole, how much force it experiences to south pole, then what is the resultant force? Force due to north pole, let us denote it by Fn. Since it is force due to north pole, let us take it as Fn, force due to north pole, Fn. So you know what is according to inverse square law of magnetism, you can find out the force. So what is that? Mu 0 by 4 pi, pole strength of north pole is m. Here we have considered unit north pole 1, divided by distance between them. What is the distance between them? Np squared. according to inverse square law of magnetism. So this is equal to what? Mu 0 by 4 pi m by np square. What is np? No plus op square. No plus op. So this is mu 0 by 4 pi m by what? No L op r L plus r whole square. Fn. So what is the direction of this force? This is north pole, this is unit north pole. So the direction must be a force of repulsion. So the direct outwards. This force is directed. This force is directed outwards. This force is directed outwards. Now we have found out the force due to north pole. Now let us find out what is force due to south pole. Force due to south pole. Force due to south pole. Same thing. There let us denote it by Fs. Force due to north pole is denoted by Fn. Force due to south pole is denoted by Fs. So Fs is how much? Mu 0 by 4 pi. Same thing m into 1 by what? Sp square. Sp square. This term is Sp. So that is equal to what? Mu 0 by 4 pi m by Sp. What is Sp? OP minus what? OP minus what? OS square. OP minus OS square. So this is equal to what? Mu 0 by 4 pi m by OP is r minus L whole square. This is force due to south pole. Force due to north pole is found out. Force due to south pole is found out. What is the direction of this force? This is a north pole, this is a south pole. So this is attractive force. This force is directed. Fn was directed outwards. This is directed inwards. This force you can mention is here. This force is directed inwards. In the examination, you have to mention like this, you have to write like this, so that the examiner can understand that the students are exactly understood which is attractive force, which is repulsive force. These are very important things to get the full marks in the answer. So one force is directed outwards, another force is directed inwards. So how to find out the resultant force? Both are along the same line. Line of action is same. So we will find out the resultant force only by subtracting one from the other. Clear? So resultant force, and that resultant force will be your field intensity. Resultant force will be field intensity at P. So we know Fn, we know Fs. We will find out resultant force. It will be Fn minus Fs or Fs minus Fn, because they are along the same line. You decide whether it will Fn minus Fs or Fs minus Fn. You know, south pole is nearer to P, north pole is further from P. So force due to south pole will be greater. So resultant force will be what? Fs minus Fn. Students can be confused why it is not Fn minus Fs, why it is Fs minus Fn, because this is nearer to P, so this force will be stronger. So resultant force will be Fs minus Fn. So let us find out the magnitude of that force. That is equal to what? Mu 0 by 4 pi, the mathematical part, m by what? R minus L whole square minus mu 0 by 4 pi, m by what? R plus L whole square. The next is the algebraic part. Mu 0 by 4 pi m r minus L whole square minus r plus L whole square. As you know, you are all science students, so you must be very much conversant with mathematics. And physics and mathematics, they go side by side. To secure high marks in physics, one must secure high marks in mathematics also. You must. So in this case, how to solve this? Mu 0 by 4 pi m r minus L square minus r plus L whole square. Let us take the LCM. What will be LCM? R square minus L square whole square. R plus L into R minus L is R square minus L square. It's whole square into what? R plus L whole square minus R minus L whole square. That is equal to what? Mu 0 by 4 pi m. A plus U whole square minus A minus U whole square is 4AB. So this is, you have to remember these things, these are all taught in schools. 4RL by R square minus L square whole square. Now we can write it in a modified form. What is the modified form? We'll keep it as such. Mu 0 by 4 pi will be kept as such. 4 will, do not cancel 4 with this because it's a constant factor. M into 2L, let us write it like this. M into 2L. Next, what remains? 2R by R square minus L square whole square. Why do we write it like this? M into 2L. Why do we write M into 2L? Because I have already told you what is M into 2L. Pole strength to distance between poles is the magnetic moment. So this is your mu 0 by 4 pi capital M into 2R by R square minus L square square. So this is the formula if the magnet is long one, but in case of a dipole, it is a very small one. 2L is a very small thing. 2L is very small, so L is small in comparison to R. L is small in comparison to R. When L is small in comparison to R, L square will also be small in comparison to R square and can be neglected. We can neglect it. So what is the field intensity? Field intensity will be equal to what? Mu 0 by 4 pi M into 2R by what? R to the power 4. L square is neglected. So this is mu 0 by 4 pi. Here you cancel R, 2M by what? RQ. So this is your final expression. This comes as a long question in examination. Define a field intensity. Find out expression of field intensity due to magnetic dipole at end on position, or what is a magnetic dipole. Find out the field intensity dipole at end on position. This comes normally as a long question in the examination. This is very important because if you prepare it, read it. Same thing will be in case of electric dipole. Everything remains same. Only in place of M there will be Q charge. Everything remains same. So this is the field intensity due to magnetic dipole at end on position. Now next long question from magnetism is field intensity due to magnetic dipole at broadside on position. Field intensity due to a magnetic dipole at a point on the equatorial line or at broadside on position. This is also equally important so far as long questions are concerned. 7-mark question. Now we will find out field intensity dipole at broadside on position. What does it mean by broadside on position? Broadside on position means the point where the field intensity will be found out must be on the perpendicular bisector of the magnet. Now the point is on the perpendicular bisector of the magnet and distance of the point from the center of the magnet is R. This is called a point on the equatorial line or at broadside position. These distances are. So unit north pole at P. Similarly, field intensity at P will be the force expressed by unit north pole at P. So let us place unit north pole at P and find out the force due to north pole, find out force due to south pole, and then find out the resultant force. The resultant force will be field intensity, and let us see whether equal to the end position or it is different from that. Field intensity. Resultant force Fn like this. This will be the diagram. Force due to north pole. Force due to north pole is equal to Fn. Same thing, same law will apply inverse square law. That is mu 0 by 4 pi m into 1 by what? Distance between the poles np square. What is np square in place of r and l? Mu 0 by 4 pi m by r square plus l square. np is r square plus l square, root over its square is r square plus l square. Mu 0 by 4 pi r square plus l square. Force due to south pole. Force due to south pole. You can denote it as we have already denoted in that case. Here it will be Fs. What will be Fs? Same thing, mu 0 by 4 pi m into 1, that is your what? Sp square, that is equal to mu 0 by 4 pi m by what? R square plus L square. Now we see that force due to north pole in the magnitude. This force is same as the force due to south pole. Both the forces, this force is directed outwards, this force is directed inwards, because this is repulsive force, this is attractive force. How to find out the resultant force? In this case, we cannot find out the resultant as we have found out the resultant in the previous case, because the forces are not in the same direction. When the line of action of both the forces will be same, then the resultant can be found out either by adding or by subtracting. But here they are not along the same line of action, therefore in this case we have to apply parallelogram law of addition of vectors. The resultant can be found out by applying parallelogram law of addition of vectors. So that we mentioned in the examination. The resultant force and the resultant force or field intensity. Resultant force can be found out by applying, you mentioned that this in the examination, so the examiner can understand that you know the things, found out by applying parallelogram law of addition of vectors, parallelogram law of addition of vectors. Resultant is, can write R resultant. Resultant force can be found out by applying parallelogram addition. One is Fs, the other is Fs, and both the magnitudes are same. Fn is equal to Fs, let it be F, because the magnitude is same. What is the value? Mu 0 by 4 pi m by what? R square plus L square. How to find out the resultant? The resultant force formula is what? According to parallelogram law, Fn square plus Fs square plus 2Fn. This you have read in first year scalar vector chapter. P square, resultant P square plus Q square plus 2pq cos theta. Two forces are there, so 2 theta. This is theta, this is theta. This will be 2 theta. 2Fs cos 2 theta root over, this is your resultant force. Fn square plus Fs square plus 2Fn Fs cos 2 theta. Now Fn is equal to Fs. So F square plus F square plus 2F square cos 2 theta root over F square plus F square 2F square plus 2F square cos 2 theta. Physics involves a lot of mathematics. So you must be very much conversant in mathematics so that you can understand all these things very easily. 2F square plus 2F square cos 2 theta. Let us take 2F square common. 2F square 1 plus cos 2 theta root over. What is 1 plus cos 2 theta? 1 plus cos 2 theta is 2 cos square theta. That is your trigonometry. 2F square into 2 cos square theta root over. That is equal to 2F cos theta. So your resultant force is 2F cos theta. Now we can put the value of F now and also the value of cos theta. What is the value of F? 2 into mu 0 by 4 pi m by r square plus l square. What is the value of cos theta? Look at the diagram. Cos theta is what? This is theta. Cos theta formula b by h. So this is equal to what? L by r square plus l square root over. ON by NP, that is L by r square plus l square root over. That is equal to mu 0 by 4 pi 2 ml, let us take it to this side, 2 ml by r square plus l square to the power 3 by 2. Why do I make it 2 ml? 2 ml because mu 0 by 4 pi, 2 ml can be written as m by r square plus l square to the power 3 by 2. Now there will be same consideration. L is very small in comparison to r. Similarly, so L square is very less in comparison to R square and can be neglected. L is less comparison to R, L square is less comparison to R square and can be neglected. So what will be your field intensity? Your field intensity will be what? Now you will get the final formula mu 0 by 4 pi m by what? R square to the power 3 by 2, let us neglect L square. So this becomes what? Mu 0 by 4 pi m by what? R cube. This is the field intensity. In n position, we have found out mu 0 by 4 pi 2 m by r cube. Now in broadside position, we have found out mu 0 by 4 pi m by r cube. So these are two long questions from this magnetism. Another long question is there. When we discuss about magnetic properties of material, dia, para, ferromagnetism, we will discuss those things in the next class.